Hello. This is the first of 3 lectures looking at evolution for hardware. If you don't know me, my name's Andy Tyrrell, and I'm actually in the department. I'm in BD005. So we've done some lectures with Steve on software evolution. Here we're going to have a look at hardware, and particularly today we're going to look at the introduction of this and some digital hardware. The way I'm going to do this is divide it up into 3 sections. Each recording will be about 15 or 20 minutes, and you can either watch all 3 at the same time, or you can split and watch them as they go on. Okay, so let's get moving. So what is evolvable hardware? So it's a confluence, a getting together, if you like, a merging of a number of areas, which includes automated design, artificial computation, computing, so the stuff you've been doing with Steve, reconfigurable hardware. So for most of you, we can think of that as being FPGAs, but we'll see it doesn't have to be FPGAs. And the hope is that we're going to end up creating autonomous systems, so systems that can do things on their own. And one example of that autonomous system is to have self-reconfigurable evolvable hardware, which is the main topic of this lecture. So why evolvable hardware? Well, one of the main objectives is to build flexible and survivable systems that are capable of, as I said, of this autonomous behavior, of self-configuration, self-tuning, and self-repair. And we can adaptively change this through reconfiguration of the hardware to provide appropriate signal processing and sensing and control in the presence of faults. Evolvable hardware techniques have already been proven to be successful in a number of areas in the field of hardware, sensing, control, and robotics. And in fact, assisting in the design of, there we've got electronic systems, but actually original designs in many areas, as we'll see over the next 3 lectures. As an example, we have a chip, actually was designed at York. It's called the Panda chip, and we'll discuss that a bit later. And one of the interesting things with chip design over the years is, as things have got smaller, you get variation across the chip because the transistors are so small. So this example here shows taking a number of small squares within the chip, and measuring the maximum frequency that they will operate at, and the colors just indicate the different frequencies across the chip. So rather than them all being the same, there is small variations across the chip. And then what we did was we actually used evolution. We used evolvable hardware to see whether we could actually make that better. And you'll see in the graph on the right there how it's come down.